All right, part 3. Moving on, another example, and they're getting more challenging as we go. This one is determine x values where the function has a horizontal tangent line. And we're given the function there, f of x equals 2 minus 1 over x, all over x plus 4. Okay, so now that we are developing more derivative rules and we're becoming more adept at taking derivatives of different types of functions, we're going to get problems that push us a little more. And instead of just take the derivative, then we got to go a little bit further. So the x values where the function has a horizontal tangent line. This idea came up briefly when we were sketching the graphs of derivatives back in 2.8. You might have remembered, whenever there's a peak or a valley, if you drew the tangent line, I'll just give you a sketch here. So, at a peak, the tangent line would be a horizontal line, or at a valley, it would be a horizontal line like that. What is the slope of a horizontal line? And of course, the slope is 0, and that's what we even said back there. Okay, so what's our strategy here in this problem? If we need to find the x values where the function has a horizontal tangent line, that means that's when the derivative is equal to 0, because of course derivatives are the slopes of the tangent lines. So here's our game plan. We're going to find the x values where f prime of x equals 0. Where do those moments occur? At peaks and valleys. Okay, let's go for it. So we got to take a derivative, of course. We'll need the quotient rule. One thing we want to do before we get started, this 1 over x. Let's think of that as x to the negative 1. Okay. So just rewriting the original function, getting it ready so we can do a quotient rule here. So, all right, let's go for it. Here we go. From this, we've got the low times d high. Let's talk about that. So d high, well, the 2 would go to 0, and then what happens? The power, the negative 1, would multiply down and make it positive, and then the power would drop by 1. So we get that positive x to the negative 2. Low d high minus, and there's the high that we just copy. Okay. Times d low. So look at the low, the derivative of that whole thing. Well, the derivative of x is 1. The derivative of 4 is 0. So the derivative of that whole thing is simply the 1. Low d high minus high d low, all over that original low squared. Okay, there's your derivative. But we're not just taking a derivative here. We need to set it equal to 0 and then solve for x. So there's no choice. We got to simplify this as well as we can all the way down before we think about solving for x when it's equal to 0. Okay. So let's go on. Here, not a whole lot happening. I'm just distributing my x to the negative 2 and distributing this minus sign really. Okay, so multiplying x to the negative 2 by x to the first. Add the exponents, get x to the negative 1, and then it goes on the plus 4x to the negative 2. And then the negative distributes, and we get there. We can combine the x to the negative 1s. Still not a whole lot. Let me cover that up just for the moment. Okay, combining x to the negative 1s, and boom, boom, boom. The rest is just repeated. Okay. 2x to the negative 1 plus 4x to the negative 2 minus 2 all over x plus 4 quantity squared. All right. This is still not simplified. It's looking a lot better, but it's still not simplified because we have these negative exponents within a bigger fraction. And that's really, there's fractions inside of fractions, right? Okay, so here's what we're going to do. We're going to multiply the top and the bottom by the same thing. But what should it be? All right, well, it turns out we've got, an x to the negative 1. We also have x to the negative 2. Here's what we can do. If we just multiply everything by x to the 2, that will cancel this one, and it will also turn that to an x to the positive 1. So all of our negative fractions will be gone with this one move here. Okay, of course we have to multiply it, to every part for it to be equivalent, but we're not going to have any more negative exponents. Hopefully that makes sense. Since I'm not in the room with you, can't see your reaction, can't take live questions. Okay, let's try it out. So distributing there, and multiplying to the bottom, that's what we would have right there. 2x to the first, those cancel, plus 4 minus 2x squared. And then we got the x squared down here now, x squared, x plus 4 squared, like that. Okay, that's looking really good, a lot better, way better. I'm still not quite satisfied. This part is technically not simplifying, but it'll help us in the solving. I'm going to put the powers here in the correct order, if you will, and write my derivative this way with the negative 2x squared first plus 2x plus 4 all over the x squared plus x to the x plus 4 quantity squared. Okay, finally, and for me, this was a whole page of work going down. We've got our derivative, and it's simplified. Oh, man. Okay, that's all right. And I mean, just think about this, right? I mean, this is crazy. Rewriting it, that's an algebra step. Okay. Then we've got one calculus step from here to here. So there's our calculus step, our derivative. And then it's algebra, 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 right? Algebra, algebra. All these algebra cleaning up and rewriting steps. One calculus step in all of this so far. Of course, there's a larger calculus concept happening. Okay, so remember our game plan. It is to set that derivative equal to 0 and then solve for x. So let's do that. I guess you could say the work is algebra, but the concept behind it all, those are new. Those are calculus. Like even the fact of knowing this, that's a calculus step just to write that. Yeah. Okay. So we're setting our derivative. I just copied our derivative there, setting it equal to 0. Let's go ahead and solve this thing. And it looks like a nightmare. I mean, oh man, we got this rational expression equal to 0. Here's the thing. It's not going to be maybe as bad as you think. Here's how we can start. Notice this denominator. Can't we multiply both sides by this denominator? Multiplying it on the left will cancel it. Multiplying it on the right, well, you're multiplying by 0. Multiply both sides by that denominator right there. And when you do, it's like this denominator is multiplying over here, and it gets a lot simpler real quick. Negative 2x squared plus 2x plus 4 equals 0. Okay. And now it's a matter of solving this. Okay, well, we're going to do this by factoring. You could use quadratic formula here. That would work. But it turns out it does factor fairly nice. If you take out a negative 2 to get started, And then the rest of this can be factored fairly quick. I'll just reveal. We can get to the end of this. Okay, negative 2, x plus 1, x minus 2 equals 0. And of course, we got two solutions. X equals negative 1, x equals 2. And that is our answer to this problem. What x values cause there to be a horizontal tangent line, or where are there horizontal tangent lines on the graph of that original function? It's when your derivative equals 0. And then, yeah, there you are. Again, I'm not going to make a Desmos video here, but this would be a cool one. Go and graph that original function. Where is it? Let's pull it back up. Go and graph this original function, and then just take a look at what's happening at these x values. We didn't even find the y values in this problem. That wouldn't be hard to do, though. Or you could just look at where they're happening, kind of look straight up and down from these points, and hey, are there horizontal tangent lines there? Right? This should be like these peaks and valleys, something like that. Okay. We've got one more example. These last two are really the big finale. This last one in particular. Not that it's like super hard. It's just a good problem, okay? All we're asked to do in this last example is differentiate. Take the derivative of what you see there. There's going to be an element to this that is new for sure, or else I wouldn't be presenting it. Okay, so we've got g of x equals x e to the x plus 6 all over 5x plus 1. Okay, what's the big deal? Well, it's got to use quotient rule. We can see that, right? We got obviously a numerator and denominator. But within that quotient rule, there will be a product rule. So I'm going to write this out. So like the big idea is the quotient rule. Okay, so I've got this numerator and this denominator. But within that, you can see the numerator has this product, x times e to the x. So when we have to take the d high, we're going to have to use product rule. All right, so this situation, when there's a major rule inside of a larger major rule, I mean, this is just something that our minds are going to have to grapple with as we keep learning more and more derivative rules, okay, because they build on each other. And really, this isn't a new idea. I mean, even within product rule and quotient rule, right, we're taking the derivative of e. We're taking the derivative of polynomials. So we're already doing rules inside of a bigger rule. But now it definitely is clear. I mean, we kind of think of these as two major rules. And so we got a major rule happening within another major rule. Okay, let's look at the details. If it's not clear to you yet why this is even true, let's check it out. Okay, so if I begin the quotient rule, and I'm just thinking low and high, and I'm really going to break this down, okay? So this is something new as well. So g prime equals, and as you can see, it's getting pretty big already. All right, g prime equals low, just the original low, and I'm going to multiply it by the derivative of the high. But here's a nifty trick. I look at that high, and I think, oh, okay, the derivative of that. That's going to require a product rule. The 6, that's going to go to 0, but I'm going to have this product rule. I would rather not think of that yet. I'm just learning these rules, like slow down. Can we show more steps? Is that possible? Yes. Here's how you do it. I'm going to write d over dx and then I'm just going to copy the high. So I know I still need to take this derivative. I'm just like pushing pause, and I'm writing it this way, noting to myself, I'll do that in the next step, right? I'm still right. This is still low derivative high. All right. I'm just like waiting a moment before I have to think through those details. Okay, so I got low d high minus high, as it is, times, and I'm going to do the same thing for the low. I mean, I could go ahead and do this one, but I'm just going to highlight, this strategy. The d low, d over dx, and then the brackets, 5x plus 1. So I'm going to do that in the next step. And it's all being divided by that original low squared. Okay. All right, so I'm looking at this, and all right, I'm just going to copy all these parts, but I'm going to go ahead and take these derivatives now. And as I look here, think, oh, right. There's my product rule within the larger quotient rule. Okay, let's do it. Here we go. So most of this is copied, right? G prime equals, there's my low, okay, times. And here it is. So let's take that derivative. We can note maybe up front that the 6 derivative is going to be 0. So that's gone. No problem. Let's just focus on x times e to the x, and I'm going to go in and underline those like I like to do, first and second. So derivative of first, well, in this case, it's just 1 times my second plus the first, as it is, times the derivative of the second, which of course is e to the x. So derivative first times second plus first times derivative second. There's my product rule right there. Okay, then we'll keep going. Minus, we'll just copy that. This derivative, well, that's 5, right? 5 plus 0. And it's all divided by 5x plus 1 squared. Okay, at this point, we've done the derivative. So if this was a test, you could stop right here. If all I'm asking for is the derivative, and again, I'll be really clear, it would say do not simplify. So you would know I can stop right there and I'm good. But just for the sake of practice, let's go ahead and simplify it. This one's actually not going to be nearly as challenging as some of those ones with the negative exponents. If we wanted to move on from here, I mean, we'd have to FOIL some things or that, but right, that we're a lot more familiar with that. So we got 5x times e to the x, all right, and then 5x times x e to the x plus e to the x plus x e to the x. And back over here, well, we can distribute the 5, and then the negative's going to come in, so minus 5x e to the x minus 30, and that's all over 5x plus 1 quantity squared. Okay. And it just so happens that these cancel out. And we get to this, the 5x squared e to the x plus, I'll go ahead and put this next, like powers of x, right? And then plus e to the x and the minus 30 over that. There's the simplified version. And we got our answers there and there. Okay, that is the end of 3.2. Go and check out 3.3. More rules.